polynomials. And we'll do much of it using tuples to make it so simple. Here we have a polynomial in x. So p of x is equal to 5 times x to the 6 minus 7 times x to the 5th, and so forth. We'll write the polynomial as a tuple. And the reason we're going to do this is so that we can learn how to add, subtract, multiply, and divide polynomials using tuples, which will be much simpler than carrying the x's around. Now, let's look at the tuple. We have an x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, but people just write x. And we're not going to say x to the 0, because if we plugged in 0 for x, you can't do 0 to the 0. So we just say that's the number term by itself. And so we just record the coefficients of the powers of x and the number, negative 123. So we've got 5, negative 7, 19, negative 25, 43, 92, and negative 123. That's quite simple. Now, if we look at our next example, we've got 12x to the 4th plus 83x cubed. There's no x squared term. You got to be careful with this and put a 0 for that term. It's 0x squared. And then we have negative 4x so, and plus 9. So we got 1283, 0, negative 4, 9. And we look at our next guy. We got x to the 4th minus 5x. So we start with the biggest power of x, x to the 4th. And we don't have an x cubed, we don't have an x squared, and we don't have a number term. But in their place, I have put 3 red zeros. So we have 1x to the 4th. So that's where the 1 comes from. So 0x cubed, 0x squares. We've got minus 5x's, and we don't have any number term. So it's actually 0. Then we look at the other way of doing them. We start with a tuple and say, what's the polynomial? So the way to do this, start with the negative 3. Don't start with the 2. And you got to count backwards. So here we're going to go number, x, x squared, x cubed, x to the 4th. So 2 is, it's 2x to the 4th. Then we don't have an x cubed. We have an x squared, 4 of those. And we don't have an x, and negative 3. Now we look at this thing. What's the 8? What is the power of x next to it? So we start with the 2. Number, x, x squared, x cubed, x to the 4th, x to the 5th, x to the 6th. So it's 8x to the 6th. Then you go no x to the 5th, no x to the 4th. We've got an x cubed, minus 3 of them. We don't have x squared, we don't have x, and then we have a 2. And that's how you can go back and forth and write polynomials as tuples and tuples as polynomials. Adding polynomials. Our first polynomial, and I've written them in boxes instead of using parentheses and commas. So we have 3, negative 8, 17, negative 6. What does that stand for? So count from right to left. Number x, x squared, x cubed. It's 3x cubed minus 8x squared, 7 plus 17x minus 6. You don't need to do that. Now here's how we add polynomials. Add straight down. So negative 6 and 13 is 7. 17 negative 9 is 8. Negative 8 and 31 is 23. 3 and 21 is 24. Negative 5, and there's nothing on top, is negative 5. It's the same for the 2. So our answer is 2, negative 5, 24, 23, 8, 7. That's how simple it is to add polynomials. Subtracting polynomials. The top one, 7, 4, negative 13, 14, negative 9, and 2. We're subtracting 3, negative 6, 5, negative 19, 8, and 12. This is an easy method to do so that you don't get messed up with negatives. We're going to change every sign in the second row. So we're going to turn it into addition. So the negative sign becomes a plus sign. 3 becomes negative 3. Negative 6 becomes plus 6. 5 becomes negative 5. Negative 19 becomes plus 19. 8 becomes negative 8. And 12 is negative 12. Okay, now we get to add. So we'll go, it doesn't matter whether you go left to right or right to left. We'll start on the left. Okay, 7 negative 3 is 4. 4 and 6 is 10. Negative 13 and negative 5 is a negative 18. 14, 19, that's 33. Negative 9 and negative 8 is a negative 17. And 2 and negative 12 is a negative 10. And that is so simple if you just turn it into an addition problem. And subtraction is simple. By the way, you can do the same method when you subtract integers from integers and change every sign in the bottom number and use tuples. Multiplying polynomials. Now, the top one, starting on the right, 4, 0, 6, negative 5, 4. We say 4, that's the number, then x, x squared, x cubed, x to the 4th. So it's a 4th degree polynomial times 3, negative 4, 6. That's a 2nd degree polynomial. It really doesn't matter what the lengths are because it's all quite simple. Now, we're going to multiply 6 with the 3, negative 4, 6 times all the numbers on the top. And we're going to start under the 6. So 6 times 4, that's 24. That's in green. 6 times 0 is 0. 6 times 6, 36. 6 times negative 5, negative 30. 6 times 4 is 24. Okay, now we can do the negative 4. We'll start under the negative 4 with negative 4 times all the top numbers. So negative 4 times 4 is negative 16. Then we have 0. Negative 4 times 6 is negative 24. Negative 4 times negative 5, that's positive 20. And a negative 4 times 4 is negative 16. And notice it's under the 4, and those are in red. Okay, now we're going to do the 3 in the 3, negative 4, 6. We'll start under the 3. So 3 times 4 is 12, then we have 0, 3 times 6 is 18, 3 times negative 5, negative 15, 3 times 4 is 12, and we just add them straight down. So we got 24, negative 16, 36, and 12, that's 48, negative 30, and a negative 24 is a negative 54, and you got 24, 20, and 18, that's 62, negative 16, negative 15 is a negative 31, and a 12. And that's how you multiply polynomials. We can apply the identical method when we multiply integers. Here we have division. Now, n tuples go into n tuples. We're dividing by the tuple 1, 3. That's a 2 tuple. So a 2 tuple goes into a 2 tuple. So when we start off, 1, 3 is going into 2, 5. And you ask yourself, how many ones go into 2? We're trying to eliminate the 2 as we divide. 2. So we put the 2 above the 2, 5. Now, 2 times 3 is 6. 2 times 1 is 2. And in division, you subtract. And 2 and a negative 2 is 0. Don't even write it down. We've eliminated that. And then 5 and a negative 6 is negative 1. And then you bring down the 3. And you ask yourself, 1 goes into negative 1 how many times? Negative 1 times. So you do negative 1 times 3, that's negative 3. And a negative 1 times 1 is negative 1. And you subtract, just like regular division. And when you subtract negative 1 and a positive 1, that's 0. That's what we wanted. But when you subtract 3 minus a minus 3, that's 6. Okay, and then you bring down the 8 and you say, how many ones go into 6? 6. So 6 times 3 is 18. 6 times 1 is 6. And you subtract, and you will get a remainder of negative 10. Now what this means is if you take x plus 3, that's 1, 3, times 2x squared minus x plus 6 plus the remainder, negative 10, you will get the dividend 2538, which is 2x cubed plus 5x squared plus 3x plus 8. Now, the same problem again. It's a new method for division. And you can do the same method with integers, which I'll show next. Now, 1, 3 goes into 2, 5 2 times. 1 goes into 2 2 times. So we have 2 times 1 and 3. That's the 2 and 6. We subtract and we get negative 1. Now move over to 3, 8. That's a 2 tuple. And you say, okay, how many ones go into 3? 3. That 3 is above the 8. and then we do 3 times 1 comma 3, and that's 3 comma 9. We subtract, and we get a 0, negative 1. So now we ask, how many 1s go into negative 1? Negative 1 times. You will see that's in the second column up. In the second row up, we see a negative 1. Now, negative 1 times 1 comma 3 is negative 1, negative 3. You subtract. So negative 1 and a negative 1, that's 0. That's what we wanted. And the negative 3 is a positive 3 added to 0 is 3. And you bring down the negative 1. How many 1s go into 3? 3. That's in the top row, the rightmost column. And 3 times 1 comma 3 is 3 comma 9. We subtract. The 3's go away. And negative 1 minus 9 is negative 10. So we've got the same remainder. And if we add the 2 blank 3, the negative 1 and the 3, that's a tuple. We get 2, negative 1 and 3 is 6, and that is the quotient from the other problem. That is a new method for division. And the next thing we will do, we will show division with integers using 1 comma 3 as 13 and 2538, which is 2,538. Here we have another example of dividing polynomials. 2 tuples go into 2 tuples, and instead of starting with x, we're going to start it with 2x. So we have the divisor is 2 comma negative 1, and we're going into 4, 6, 5. So 2 goes into 4 2 times. Okay, so now 2 times 2 is 4, and 2 times a negative 1 is negative 2. We subtract. The 4's go away. That's what we wanted. And then we have 6 minus a minus 2. That's 6 plus 2 is 8. We bring down the 5. Then we say how many 2's go into 8? 4. So now we do 4 times 2 comma negative 1. That's 8 comma negative 4. We subtract. The 8's go away, and we have 5 plus 4 is the remainder 9. And if we wanted to check our answer as polynomials, we could do 2, 4 times 2, negative 1. And that would give us 2, 6, negative 4. And then if you add the remainder 9, you would get 5. And that is the dividend, 4, 6, 5. That's 4x squared plus 6x plus 5. Evaluating polynomial tuples. Our first examples will deal with what's the polynomial equal at when x is 0, 1, negative 1, 10, and negative 10. Now, we have the polynomial 4, negative 17, 3. That stands for 4x squared minus 17x plus 3. If x is 0, we have 4 times 0 squared minus 17 times 0. All that stuff is 0. Then 3. So p of 0 is 3. What's p of 1? Wherever you see x, you put 1. So 4 times 1 squared, that's 4. Minus 17 times 1 is negative 17 plus 3. So we just got to add the coefficients up. 4, negative 17, and 3 is negative 10. P of negative 1. We have 4 times negative 1 squared. That's 1. But negative 17 times the negative 1 is a positive 17. And then we have 3. So if we add 4, 17, and 3, we get 24. P of 10 is the tuple turned into an integer. Now, here's how you do it. We start on our right. 3 is okay. It's a single digit. We want to make the next digit a single digit. We can add multiples of 10. So if we add 20, we will get 3. But if you add 20, you must take away 2. So we have 3, and 20 and negative 17, that's 3. And 4 minus 2 is 2. So that's 2 comma 3 comma 3, which is 233. We will now evaluate the polynomial at negative 10. So what we have to be careful of, if you put in negative 10 for x squared, it's positive 100. But a negative 10, where we have negative 17x, x is negative 10, that's going to change the sign of 17 to a positive 17. So p of negative 10 is 4, 17, then 3. Bring the 3 out, so to speak. Bring the 7 out. Add the 1 and 17 to the 4, you get 5. So that's 5 comma 7 comma 3, which is 573. Now, if you want to know more about tuples and how this was done, there are several videos on tuples that I've done. Tuples, and in general, a more detailed video is Tuples 101 Basics, and there's also a video, Tuples and Polynomials. That's rather long, that goes into much greater detail. Evaluating polynomial tuples again, the remainder theorem. Now, I'll explain that as we go along. Now, P of x is the same one we used before, 4x squared minus 17x plus 3. P of negative 2, wherever you see x, you put negative 2. We will have 4 times negative 2 squared minus 17 times negative 2 plus 3. Okay, 4 times 4, 16, minus 17 times negative 2 plus 34 plus 3, 16 and 34, that would be 50. Add a 3, that's 53. Now, we will divide 4, negative 17, 3, the tuple, by the tuple 1, 2. That stands for x plus 2. You have to ask yourself the question, what do you put in for x to make x plus 2 0? Negative 2. So if we were evaluating, say, at 5, you would divide by 1, negative 5. In other words, x minus 5, what do you put in to get 0? 5. Say we want to evaluate at negative 4. You would use 1, 4. X plus 4, what do you put into x to make x plus 4 0? Negative 4. So that's why we have the opposite sign. So it's 1, 2, not 1, negative 2. Now, 1, 2. 1 goes into 4 times. That's above the negative 17. Now we're going to do 4 times 1, 2. 4 times 1, 4 times 2, that's 4, 8. Okay, you subtract. The 4's go away. It's negative 17, and you go add to it negative 8. That's negative 25. Bring down the 3. How many 1's going to negative 25? Negative 25. So now we're going to do negative 25 times 1. That's negative 25. 25 times 2, that's negative 50. You subtract. And so that 25s will go away, the 2 negatives, but then you add 3 minus a minus 50 is plus 50, and the remainder is 53. So the remainder theorem says, instead of plugging in negative 2, if you divide by 1, 2, the remainder is the value of the polynomial at negative 2.